Hey class, hope everyone's doing well. We got our next topic of power and efficiency. So this is just going to be a little intro video. I will do 2 example questions looking at these 2 things, but let's talk about power first. So what power is, it is basically how fast work gets done. So again, let's use something on my table. I have a few things on my table. Let's use this, the actual device to actually turn on the projector. So our little remote here. If I apply a force and it goes a certain distance, I've done work. If I do it faster, I still do the same work, okay, in the sense of like it's still in the same distance, but I've done it a lot faster, okay, which is kind of our power. So our power, and you can see our formula right here, but I'll draw a little bigger, is our work divided by time. So how much work you do divided by time. So basically this is like our power output. So again, if I were to lift a box a certain height, if I do it very slow, I have a lower power output because I'm not doing it as fast. If I do it really fast, well, I have more power, okay? So an example that I use this in when I do it in class is I give everyone like a 20 kilogram weight, like 45 pounds, and then I ask you to do it 10 meters. I ask you to try and do it in like one student to do it slow and one student to do it fast, and who's more tired at the end? And obviously the student that does this fast is more tired because they did more power, okay? They had to do it faster, okay? So that's kind of what power is. How much work you do divided by time. So not too bad. It kind of just, again, works with all of these, our energy questions, because again, work is energy, and then just we need one little thing of time in there. And then efficiency. What is efficiency? When we're talking about our energy efficiency, when we talk about power or talk about work, they all kind of are the same thing. It is whatever output you get divided by the input. Okay, and this could be power and power. If I want to erase this, that could be like energy and energy, but it's basically the output divided by the input. Okay, so if I try and actually, like if a crane is trying to lift something, okay, and it puts so much power in, but the actual thing is only raising a certain speed, the actual input that we're getting is not so. I'll do a better description when I go through a question here, all right, instead of trying to describe. There's also a really good video that I attached to the helpful videos here. It says intro video for efficiency. It's just on efficiency. It's not done by me, but it's a really good video looking at efficiency. It's only 5 minutes. Go check it out. It'll make a lot of sense. But let's go through a couple of questions when we look at this, okay? And I realize I don't have this on, so it's going to take a second to boot up. Let's look at a couple of questions for power and efficiency. And if you look at your power and efficiency practice sheet, I'm just going to do questions 1 and 2 on here. Question 1 is talking just about power. Question 2 is talking a little bit of power, and then as well some efficiency as well. Okay, so I'm going to bring up my worksheet here, which is yeah, right there, and it is slowly coming up here. Okay, slowly coming up. So let's get this and get rid of those, and let's do this. This is what is the power output of a 60 kilogram person who climbs 5 meters in 15 seconds. So mass equals 60 kilograms. Height is 5 meters, and we have a time now of 15 seconds. All right, so what is the work done? Again, when we think of the power, there needs to be some kind of work done. Work is our change in energy. So basically, someone went to a certain height, so they changed their height, which means they did some potential energy. So let's find the potential energy that this person has. Potential energy is 60 times 9.8 times 5. And I get a potential energy of 2,940. And this is the work done. What is work? Work is the change in energy. I went from 0 meters to 5 meters. That's my work. So there's my work. It was the potential energy. Now, the nice thing is power just equals my work divided by time. So I'm going to take this 2,940 and divide it by 15. And so power here is going to be 196. 196. Now 196 what? What is my units? For this it is watts. Okay, you may have heard watts if you have taken electronics, how much power an actual device has when we talk about watts, but when we look at physics, power is measured in watts. Watts, okay? I don't have to put the whole watts, all I have to do is put a little W if I want. So 196, and I'll leave it at little W, watts. Cool, there's question 1. There's a little bit about power. Let's do one more question about power and add efficiency in. All right, we have question 2. Machine rated at 2,500 watts. There's our W, so we have power. Power equals 2,500 watts. Okay, lifts an object. There's a mass of 150 and a height of 40 meters. Okay, in 1 minute. 1 minute. Now, I do not like minutes. We do everything in seconds, so 60 seconds. Change that right now. Time, 60 seconds. All right, what is the efficiency of this machine? So basically, it says a machine rated at 2,500. So this is the power, like, output. Okay, so this is the output. This is what it should have done. Okay, so anytime that machine does some power, that's the output. Now, what does the input mean? It means, like, what did it actually do? What did it actually lift? Well, let's try and figure that out. Okay, and so let's go through this. We have to figure out power, so we have to figure out work over time. I have the time, I need to do some work here. And so again, this thing is lifting an object at a certain height. So our work is going to be our change in energy, or like potential energy here. So potential energy equals 150 times 9.8 times 40. So what was my potential energy here? I have 58,800. Again, that is my work. That's not my power. That's just my work. My potential energy. Okay. If this thing, yeah. All right. So my potential energy was basically 58,800. It started at 0. It went to this new height. So that's my change in energy. So my change in energy is my work, which means that's how much work was done. 58,800 joules. Now we're not done. That's not the power that it did. That's just the work that it did. It did it in 1 minute. So let's divide this by 60 to actually see my power. So my power is going to be 58,800 over 60. So this is going to equal 980. 980. So there's my 980 watts. Okay. Now I think I just got a little mistake here. We're going to turn this to our input. Okay. The input by the machine is what the machine does. The output is what actually happens. So my mistake. Okay, so the power in here is like how much power does the actual machine put in. The output is what is the output, like what does it actually happen? What happens in front of you? Okay, so we have our power input, we have our power output. There's the power that the machine actually did. Okay, it lost a lot of energy obviously because of heat and friction, and most machines aren't actually that efficient. Again, our cars are only about 30 to 40% efficient, which means all that gas energy only actually like 30 to 40% makes our car go forward. Most of it turns into heat and other stuff. And so, yeah, unfortunately machines aren't that efficient. Let's figure out how efficient this is though. So if I want to figure out our actual efficiency, let's go this. Efficiency equals our output divided by our input. And you should always get a decimal. That's the big thing. You should always get a decimal because to turn it into a percentage, you can't be over 100% efficient. I can't put in a little bit of energy and a lot come out. Whatever energy I put in, that's the most I can get. So the most I can ever get is 1. We're not going to get it here. Efficiency here is going to be my 980 over 2,500. And so I get 0. I have the answer somewhere here. 0.39. So 0.39 or 39%. So this machine was 39% efficient, okay? It gave in, like it gave 2,500 work. It only ended up actually doing 980 watts of work, or sorry, of power. And so it was 39% efficient. All Alright, I'm going to do one more video looking at 3 or 4 questions, 2 from a practice sheet, and then 2 from some other work that I was going to give out but didn't fully put out there. That'll be in the next video. As well, there's one other video looking at power and just the intro of it and how to kind of look at power. So there you go. We'll see you for the next video soon. Alright, thanks class.